Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 9 elite math students to today's session. The session is on module 11 lesson 6. Today's video is part 1 of factoring quadratic trinomials, and our learning objective in the session would be to determine the factors of trinomials with a leading coefficient of 1. So before we move on to the video, a humble reminder, a kind request to subscribe to the channel if you haven't, and if you're finding the videos useful, click that thumbs up button and press the bell icon so that you don't miss my future videos. So let's now dive into the video and see what we are learning today. So the first case is where you factor trinomials with the leading coefficient of 1. So if you see, the standard form of a quadratic function is ax square plus bx plus c. So a is the leading coefficient of x square. So if a is equal to 1, that means the equation reduces to this form. Then we say that it is the case of the trinomial with leading coefficient 1. So you have to find the two integers m and p such that the sum of b they have m plus p equal to the middle term, which is b, and m multiplied with b is the last term, which is c. So sum of b and product of c, and then you can write this as factored form x plus m multiplied with x plus p. So for example, so this is something which you have to remember. This method also has another name called middle term splitting. Okay, now for an example, you have this equation x square plus 8x plus 15. Then we have to have two numbers m and p such that the sum is the middle term 8 and the product is the last term 15. Okay, you need this. So how it is possible? You will find factors of 15. Which two numbers multiplied gives 15 and added gives you 8? So those are 3 and 5 definitely. So these are the two factors. You can write x plus 3 multiplied with x plus 5. Now even if you change the order, answer will not change. Coming to a prime polynomial, a polynomial that cannot be factored, that is, it cannot be written as the product of two polynomials with integer coefficients, is called prime polynomial. Just like a prime number, it cannot be factored. So simply you will write that it's a prime polynomial and it cannot be factored. As an example, you can see x square plus 1. This is a prime polynomial. It cannot be factored. However, if I write x square minus 1, then it can be factored using difference of square. So you have to not get confused between the two. This is a prime polynomial, that is, it cannot be written as the product of two polynomials with integer coefficients, or it cannot be factorized. However, x square minus 1 can be easily factorized. Let's do the check. Write the factored form of each polynomial. If the polynomial cannot be factored using integers, write prime. So the first polynomial which is given is x square plus 7x plus 6. Here in all the three cases the leading coefficient is 1. So we are going to use middle term splitting. We need two numbers such that their sum is 7 and the product is the last term 6. So very easy. 1 and 6 are going to help you. So we can directly write this as x plus m multiplied with x plus p, which can be written as x plus 6 multiplied with x plus 1. Now remember, if we change the order, if I write x plus 1 first and x plus 6 later, it is also correct. The answer will not be changing. Both are correct answers. Let's look at this one. Now the two roots, sum has to be the middle term minus 8 this time, and the product has to be the last term 12. So what can be factors of 12 which can give you minus 8 on adding? So we can take 2 and 6, and because of the negative sign I have to take both of them as negative. So if you can check, minus 2 plus minus 6 gives you minus 8, that's correct, and minus 2 multiplied with minus 6 gives you 12. So this is the correct answer. So the factorization of this would be x plus m multiplied with x plus p, which is equal to x minus 2 multiplied with x minus 6. Or again, you can change the order and write x minus 6 first and x minus 2 later. Let's do the last one. Here the two sum of roots would be the middle term 3, which is positive, and the product of the roots would be the last term minus 40. So what are the factors of 40 that can give you 3? Let's see. So 4 multiplied with 10 is 40, but it will not help us. Then 5 multiplied with 8 is also 40, but that will help us. So if I take minus 5 and plus 8, let's see. Is it meeting the criteria? Minus 5 plus 8. It is giving 3, correct? And when you multiply, it is giving minus 40. So that's correct. So the answer for the factorization of this would be x plus m multiplied with x plus p. So x minus 5 multiplied with x plus 8. Or again, you can change the order, x plus 8 multiplied with x minus 5. So both are correct, and this is how you do the factorization when the leading coefficient is 1. These are some of the unsolved questions from your math book. Here you need to factor each polynomial if possible, and if it cannot be factorized using integers, then you write prime as the answer. So from this screen we are going to solve question 8, and we're also going to solve question 5. Let's do it in the next slide. Check your answers and solve all other remaining parts. So let's do factorization of the quadratic trinomial which is given to you. The method that we are going to use is middle term splitting. So the polynomial or the quadratic trinomial that I'm taking here is m square minus m minus 42. So if you see carefully, the leading coefficient is 1. That is the degree term which is having degree 2. Its coefficient here is 1. So this is the method called as factorization when the leading coefficient is 1. So what do we have to do? We have to choose two numbers a and b such that the sum of them is the middle term. So the middle term here is minus 1, and the product of the two terms is the last number minus 42. So now what can be those two numbers? Let's see. So we have to factorize 42 negative 42 to get those two numbers. So we can write, can we choose 7 and 6? Let's see. And because of the negative sign, one has to be negative. So one is negative 7, one is plus 6. Let's see if this works. I can break the middle term as minus 7 plus 6m minus 42. So if you see, I take common m minus 7, and here it is 6 m minus 7. So the two terms can be m plus 6 and m minus 7. So that is the middle term splitting. We have got the two factors, or we have completed the factorization. You can also write the factor as m minus 7 first and m plus 6. Changing the order does not change the answer. Let's take another example. This is h square plus 15h plus 44. Again, here the leading coefficient is 1. So we have to choose two numbers, say m and p, such that their sum is the middle term 15 and their product is the last term, which is 44. So what can be the factors of 44? 4 and 11. Let's see if they work. Yes, they work perfectly. So you can break the middle term as 11h and 4h, and then combine, take the GCF, group the two terms together, these two terms together. So h is common, h plus 11. Here 4 is common, the GCF, h plus 11, same bracket. So you can write this as h plus 4 and h plus 11. So that completes the middle term splitting of the quadratic trinomial. Here we have seen the case where the leading coefficient is 1. So the two roots or the two factors can be found in this way. So that brings us to the end of today's session. If you found the video useful, give it a thumbs up and also press the bell icon so that you don't miss part 2 of this video where we talk about the case where the leading coefficient is not equal to 1. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.